in your AQ physics, right? All right,
Yeah. Yeah.
good. Now let's start with work. If I just ask you, so what do you know about work and how can you define?
Um, Work done is power times time.
That's a good definition. But the thing is that the definition that you provided is not one of the fundamentals. Like, so if we just talk about, let's say, if we just can talk about some definitions of it, right? So you have to tell it with the fundamentals, right? So, for example, if it's a question written over here, define work done, right? So
Yeah.
definition is provided is going to be a fundamental definition. Okay. So the work
Yeah.
done, yeah, the work done is basically is equal to force. The work is basically is equal to the force times the displacement, right? And by
Yeah.
displacement, by displacement, I really mean is that that object has changed in position due to that force, right?
Yeah.
Now, for example, let me just give you a common example. Let's say you're pushing a car, right? And when you're pushing a car, right, it will cover some distance over there. Okay. So the
Yeah.
amount of energy that you have got has converted to work. Now, one thing over here is that the both of the direction of the force and displacement must be parallel. So if you want to find out the work done, right, the
Yeah.
direction of the force and the displacement must be parallel. Now, why I'm saying? Now, what's the reason behind this? Let me tell you first. Let me just write it down and tell you. All right. Now, let's say this is a surface over here. Okay,
Yeah.
and I'm moving this object. This is someone standing over here, and
Yeah.
he's applying some force. Okay,
Yeah.
let's say that he's applying a force of 20 newtons, and this object has displaced from here to here. So the difference between that now we're going to check the difference between the two positions, right?
Yeah.
This is what you're actually going to do. So let's say the difference between the two positions, or the displacement between the two positions, is like 20 meters. So the next thing I'm going to do, I'm going to look at the formula. This is written the force is multiplied by displacement, right?
Yeah.
So what I'm going to do over here, I'm going to do like this. I'm going to multiply these like this. It's going to be the work done would be 20 times 20. It's going to be 400. And then, what's the unit for the work done?
Is it
Joules.
in
Same
joules?
as same as energy,
Yeah, joules.
right? Why does it have same energy? Okay, the thing is, I'm gonna tell you that after when we get on with energy, right? So first we have to understand the concept of work done. All right,
Okay.
right now. So this is the basic. You can say an explanation, the easiest way how to define the work. Now there are some different cases, right, where
Y-
we have to work out in order to find the object, the work done by the object, and especially when it is on an inclined plane, or let's say it is the force is acting at a different angle. Now, what I mean
Yeah.
by this, let me tell you. Like I told you one thing, the direction must be parallel. Now, why
Yeah.
I said this? Because the force is moving in this direction. Can you see the direction of force? The force is in direction, right to the right, and the
Yeah.
displacement is also to the right. As you can see, right,
Yeah.
that force is in the right direction, and the displacement is also in the right direction. So,
Yeah.
can you see these arrows? This is the
Yeah.
right direction of force, and it's the direction of displacement. So, both of these forces are parallel to each other. Okay.
Yeah.
Now, another question is, what if I apply force at the above like this? Will there be a work done?
Yeah.
No, I'm talking about this one. Let's worry about this one. Let's move this. All right.
Yeah.
Will the object move?
No.
Why?
Because it direction must be parallel.
Exactly. The direction must be parallel. This is what I'm trying to explain over here. All right. So
Yeah.
now, what happens if the force is not in a horizontal plane? Instead, it is acting on a certain angle. Acting on a certain angle. All right.
Yeah.
Let me draw another diagram. Okay. This is an object. Right. This is an object over here. Okay.
Yeah.
And let's say then objects acting on a certain angle. With the and at the angle that is making to the horizontal is basically, let's say, 30 degrees. So now it's very common sense over here. So if you're gonna apply force in this direction, right? Can you see the direction from to the, let's
Yeah.
say, southeast, right? Like this.
Yeah.
So it is very common sense that the object will move like this, right?
Yeah.
But now the problem over here is that the direction of force, the direction of a force,
Yeah.
all right, is
Yeah.
not parallel. It's
Yeah.
not parallel to the direction of a displacement, right? So
Yeah.
what are we going to do? Only the we are going to make the components of these forces, right?
Yeah.
So if because the thing is, since it is coming at a certain angle, right? So it will have the component of forces on the horizontal force and the vertical force.
Yeah.
Now, why does it have vertical and horizontal forces? Because it is coming at an incline, right?
Yeah.
Because this inclined force is basically a resolution of these two forces. Now, let me just tell you one thing. Now, if I have two directions like this,
Yeah.
right? Now, can you see the arrows? Can you see the arrows? Now,
Yeah.
these are the two vectors. Now, if I just ask you to draw a resultant of these forces, right? What are you
Yeah.
gonna do? You got a resultant force like this. Getting a point? This
Yeah.
is the resultant vector over here. So now, what are we doing over here? We are basically reversing that. We're using the resultant in order to find the components.
Yeah.
Getting a point? We are basically reversing using the reverse methodology, you can say, right? We were reversing. We are basically reversing the method over here.
Yeah.
Are you getting bored?
No.
All right. So we can draw forces like this and force like this. Can you see the yellow lines?
Yeah.
Now, which of these two forces are causing this object to move?
The one at the bottom, like the yellow
With the-
one,
Yeah, the one
underneath
on the
30
bottom.
degrees. Yeah.
Yeah, this one is actually this component over here is basically the main reason. Sorry, this one, the one that's below is basically the main reason for the object to move, right?
Yeah.
Because moving in this direction. So we can work out with this component and we can leave the whole of that. So now, as you can see, they are
Yeah.
basically forming a triangle, right? If you just look at the, if you just do the resolution of force vectors over there, and you draw vectors and go to the hexagon group like this over here. This is 30 degrees. and the component over here, and this is basically 2 Newton. And so now we take this component. So as you can see, this side is basically adjacent to the 30 degrees. So if you must have studied trigonometry and maths, so you must have studied so, ka, tua. Do you know this? Uh, yes, yes, Mishal, are you there? Mishal, hello. Mishal, if you can hear me, just write, can you write on chat box? Yes, I can. You can. The confirmation.